Welcome everyone so far. We'll wait for a few more people to log on here and we'll get things started. Thanks for being on time and ready to go. Welcome again. We're just gonna give a couple minutes here for any latecomers to join up and we'll get the ball rolling here probably 2 minutes at least. And I'll give another 30 seconds or so. We got a few people just sort of popping on, so I'd hate to miss it there. So yeah, just 30 seconds here and we'll get started unless there's any objections. It seems like we've got a good group of people together anyway. I appreciate everybody for coming and logging on during whatever time of the day it is for you. I'm out on the West Coast, so bright and early, 8 a.m. here. And David, my colleague from DCC Solutions, is in Quebec there, back East Coast. Um, David is a lead associate and has so much experience when it comes to sustainability and products coming into the market. I've been in the industry for many years as well, just doing A&D presentations, things like this, trying to bring new markets out to market or bring new products out to market. So the basic idea behind this presentation today is we're going to go over sustainable dry acoustic solutions. There's a lot of reasons why we're kind of at a perfect point right now where all of the things we're going to go over today are becoming not only relevant, but very important in buildings. So as we go through this, please let us know if you have any questions. There will be a Q&A portion at the end of the presentation. But if you don't understand something, please speak up. I prefer you interrupt me than you not understand something fully as we move through the presentation. Um, I'll briefly jump into the objectives of this presentation here. So we're going to do a basic introduction like I've been doing, define some of the basic acoustic principles, understand how noise travels through wood structures, explore light wood frame and floor ceiling assemblies, recognize the differences between wet and dry solutions and their benefits. We'll discuss sustainability and the budget impact as well. So what do we do on a day-to-day basis? Who is Acoustic? What are we? Acoustic actually represents a number of brands. So as I mentioned, DCC, David, who's here with us today, they represent Firmacell coming out of Germany, a James Hardy brand. We also represent Suprema and all of their acoustic lineups. So not their building envelope products, but anything acoustic that comes out of their portfolio. We also now work with Pack International, who are very well known for their acoustic clip and hanging systems. So very wide portfolio, I'd say. We try to have literally a solution for everything, no matter what the building structure type or needs of the client. So that's essentially who Acoustic is. We spend a lot of time dealing with acoustic complaints and in-law suites, things like that. The negative perception of wood buildings is a big factor, and it's constantly something that I deal with with builders and developers. Code regulations dealing with sound, weight, sustainability, fire. All of these are very important things that we deal with, and the abundance of products and misinformation on the market. One of the most important facts that we probably bring up during this presentation is this point. There's so many products on the market, many in which just state, they have an IIC or an STC or even a LEED, association. All of these things that products cannot have on their own, but yet they tend to be marketed that way. So we'll touch on quite a bit of this as we're going through the presentation. So in context, why is all of this important? Well, 65% of multifamily residents have experienced a noisy neighbor, whether they've made a public complaint about it or not. It's just a typical fact of living in multifamily buildings. I just moved from a single family home to a townhouse, and even though it's only a duplex, the sound propagation through the building is more than I expected. The number one cause of avoidable resident conflict is noise. It's that easy. As we know, remote work went up in Canada from 4% to 32% due to the pandemic. So that was a big change. So a lot more people spending more time in their homes. New York noise complaints rose by 42% in the first months of confinement. So you can tell that these issues became very well known very quickly. The waking time spent at home went from 50% to 62% at time in 2020. Again, mostly because of the pandemic, but we've all changed our lifestyles since that point. We haven't become accustomed to going out and going to pubs and events as much as we used to. It's a real struggle to just leave home nowadays. Hybrid workplaces have become the norm. 17% of businesses say back to office has been something that they're looking to do as soon as possible. But there's a lot of people still working from home, even on partial basis. So noise has never been more important in multifamily buildings. As we move on, what I'd like to cover first is some of the basic acoustic principles. So these are the principles that we use, RWDI would use, most architects like yourselves would be aware of. Let's just touch on these quickly so you're aware of them. It doesn't get too in depth. We don't want you to be the acoustic experts. We want you to be able to call on us as your acoustic experts. But these principles at least give you an idea of what you really do need in a structure to help with noise propagation. The first and probably the most important one is mass. We've seen this for years. with concrete, concrete used in either concrete building or a concrete topping, typically just concrete used to stop sound moving across a space. One of the other most important factors is flanking. So when I stomp, that energy does not stop where I stomped, right? That energy travels through the floor to the beams, to the joists, to the ceiling. It moves throughout the entire structure. So, how do we stop that? Well, the most viable way that we have right now is decoupling. So, in a perfect world, perfect decoupling would be, we've all seen Back to the Future, the hover car, right? It doesn't touch the ground, right? Even when they hop in the car, it still hovers. That would be perfect decoupling. We don't have hover technology, unfortunately. So right now we rely on, you know, things that we like to promote, like textile products. Really help with the next factor that comes up is ceiling. So not the roof you're ceiling, but the ceiling as in room for space to or for sound to come into that room. I usually describe this as a hotel room. The most typical situation is I don't hear anybody above me or below me in a hotel, but I hear every bit of noise that comes through that gap in the door. So that is an example of ceiling. Where you might see this on a more typical basis would be the ductwork in a building or junction boxes that are back to back, wall to wall in a party wall. Those can be real issues for ceiling. The biggest one lately has been pot lights. Pot lights everywhere. Pot lights here, pot lights there. It's all accounting and basically causing issues with ceiling in that space. So, really important factor. It's something I don't deal with a lot on day to day, but just being aware of it can actually help out quite a bit. Void treatment. So, void treatment is how do we treat a void space? So whether it's in between a joist, floor ceiling assembly, are we going to fill it with batting? Maybe we're going to half fill it. What can we do in a floor system to add to take care of some void treatment? So these are all different factors that you would keep in mind when you're trying to take care of an acoustic space. All of these five factors, very, very important. And if you can understand these, moving through the rest of this presentation should be easy. When we talk about flanking mitigation, like I mentioned, it is not just one path, right? When I stomp, that energy didn't just stop there, right? This shows a basic example of 5 quick paths that energy can travel just from one dropped item. Now, when we talk about mass timber, this increases even more. I recently saw an engineering presentation where they said there are 12 points of transmission points of flanking in a mass timber building. So very, very important in these wood structures that we do as much decoupling as possible to try and mitigate this. Now, the way I always talk about flanking is where's the best place to stop it? Well, you want to stop it at the transmission point. So where you see that blue ball dropping, the more you can do there to decouple is going to help that flanking from stopping. We can add more treatments in this structure, but let's try and stop it at the source. That's the most important part. The drawing on the left kind of shows you how sound is measured. Here's a sound source on the one side traveling through the wall. How much of that sound traveled through that wall? It's a same thing when we're talking about a floor ceiling assembly. How much of that sound travels through that assembly? This is a very important slide when we're talking about people's perception of sound. Now, we usually play this as a bit of a game, and I can't get you guys to all put your hands up or stand up, but kind of play in your head because we all have different perception of sound based on our environment, our working conditions. These all play a really important factor. So this doesn't necessarily dictate what your age is. It might dictate what your ear's age is. What's the right word there? So let's go through this very quickly. If we talk about 8 hertz, this is a sound wave that everybody should hear. I apologize if your speakers are turned up too loud. This is not a great noise. I'll stop it there. That's probably enough. Everybody can hear it, hopefully. So that is 8 kilohertz. Everybody should be able to hear that sound. If you cannot, please see your local doctor. Not just kidding. Well, maybe I shouldn't tell you what to do and not to do. Here is something that everybody under 50 years old should hear. So again, pretty annoying noise. I can hear that one, but it's we're starting to hear a little bit less of it. This is something under 40 years. I can just barely hear that one. I'm 44, and I've worked on construction sites my whole life, so that's just barely there. And I've got the source sound here. Let's hear. Let's see how everybody does on this one. Other than the click of my speaker turning on, I didn't hear anything there. So the idea of this isn't to shame anybody or force you to go see your local doctor. The point is just to let you know that people's perception of sound is different. The bass sounds, the high sounds, low frequency, high frequency, we all hear things a little bit differently. So person in unit A may have a different complaint than somebody in unit B. So really all the slide is doing is bringing you to that awareness. So let's get into the two main points when we're talking about measuring sound in buildings, in multifamily buildings. We know that airborne noise, the sound transmission class STC, is required by code in Canada. And that trickles down to your provincial code, to your local city code, all the way down. So everybody is on the same basis here. The minimum STC is 50. Now, the ASTC required, so this is what we call the apparent flanking. So the ASTC of the building minimum would be 47. Now, what does that mean? Well, sound transmission is typically anything like my voice traveling across the speakers through your room, your TV on, telephone ringing, your dog barking. These are all examples of sound traveling through space. And like we talked about at the beginning, one of the easiest ways we deal with this is with mass. That's been traditionally the easiest way to go about it. Now, the ASTC, as I mentioned, is what's tested on site. So what they're doing is they're testing in multiple locations in a room to account for the flanking going through the room as well, or through the structure as well. So apparent STC is what you're going to see on a lot of reports coming back now, rather than what was F before. It used to be F for field. Now you're going to see ASTC. And this is what code is brought on as well. So very important to acknowledge this. The diagram below shows how it's tested. You know, a speaker in one room, a sophisticated microphone below in the other room. And basically, yeah, it's measuring the decibels that start from that sound source and how many end up at the microphone. There's a very complicated algorithmic curve that's done in math that computes it all after the fact, but that then brings you to your actual on-site ASTC. I hope I've explained this one clear enough because it's a really important one. If not, please let me know. We'll have some questions there at the end. Impact noise. So this is the other side of the coin. We talked sound transmission. Now we talk impact, right? We were talking about that banging being something that happens quite frequently. Footfall, chairs dragging, things like that. That's impact noise. So impact noise in the US has a required 50 IICs. That's impact isolation class. Unfortunately, in Canada, there is no required IIC number. This gets challenged sometimes, but the fact is there's no required number. There is a recommended number, as you can see, of 55. So it does force this to be a little bit neglected sometimes by builders, by developers, but it's just a matter of just meeting code. You know, that can be the easiest way to, or not the easiest, but the most cost-effective way of going about doing an assembly is just meeting code. So 55 is recommended, but it's not always met. The AIIC, again, isn't required. There's no required apparent flanking IIC number in Canada. Now, is this changing? We are seeing that in the new the new coming out code in 2030 from Canada will dictate an IIC, a minimum IIC required. We do not know what that number will be yet. We're hoping it will be the same at least as the US and hit that 50 marker, maybe higher. 55 would be amazing. But the good news is that's coming. Where I see that having a huge impact is a lot of these companies that are promoting, underlay products that have IIC 77 or an IIC 80 something. My hope is that it's going to put an end to a lot of those because they're not going to be able to market themselves that way if they're not able to really achieve those numbers. So, hope for the future is how we'll leave this slide. And as you can see on the diagram there, that's measured more with what's called a tapping machine, which we have a bit of an illustration later on to show you. But same type of thing. They measured the decibels at the top and how many come through the tested assembly. So here is that slide telling you, yeah, what is tested, right? What what is actually compiles these IIC and STC numbers? Well, it's all of these different assemblies, right? Um, that's why you can't just state my product has a 72 because yes, while it may have a 72 on that upper left-hand drawing in the corner, it's not going to have a 72 when we're talking about, the bottom, the right hand. They're different products, of course, but I'm just trying to show you different assemblies with the same product are going to equal different numbers. So we're always testing that assembly. We're not just testing a product at any point. No product, even a delta. This is important. Every presentation, somebody pops up afterwards, and I'm sorry if you're that person on here, but says, "What about a delta? I love delta." A delta is a little bit better, but it still is only tested on one assembly. It's tested on that same concrete assembly that everybody's cheating to get that 72 number on. So when you go to, say, a website a little different, maybe like Acoustic, you'll actually see multiple test results for a product. It'll actually say a 9-meter slab will have this result. Here it is on a light wood frame structure with a concrete topping. Here it is with this. That's how you get real data. It actually can be helpful rather than a detriment just looking at a product that gives you one number that you have no idea where it came from. And I probably preached on this one too long, so I'm going to move on, guys. Uh, all right, so this slide gives you a quick little video here. So that's an example of what the tapping machine sounds like. I'm going to fast forward a bit just to skip to the end. Here they are now downstairs in the concrete building. So, right, concrete building, amazing. If I did that same test in a light wood frame building, it would not be this quiet. Impossibly. It just would not happen. You could have, like I said, the exact same product on that different assembly, and you're going to get a completely different reaction. Now, I love this slide because this slide triggers the emotional response. You're going to get builders that have not ever heard the difference between a 50 IIC to a 55 to a 60. And the reason this is important is because, as I kind of described before, this is an algorithmic curve. So when we go from a 50 to a 60, we're literally doubling the acoustic value of that assembly. So listen carefully. We're going to start off with a 50 and move up. Amazing, right? Hey, I love that picture. But it is truly amazing that 10 points can literally double the value. And that's why when people are just stating these 70 and 80 numbers, it really hits me at home because once you've gotten to 60, every point you're, like I said, that algorithmic curve, right? You're now climbing a steep mountain, that you didn't start at the beginning. You started on this, easy little trail. Once you've got up to the top and you're going almost straight up, it becomes very difficult. Every point you achieve past there is more and more difficult. So, very important just stating that when we're looking at a slide like this. So let's talk about the propagation of noise in wood construction. That's kind of the important part, right? Can a light wood frame structure achieve or be as efficient as a concrete structure. And the crickets, I know all your mics are muted, muted, but the crickets are true. It can actually do it, but look at all the effort that had to go into that light frame structure to get there. I have three, four different acoustic products in that assembly. That concrete structure, one. You see, one product, and we'll touch on why as we go forward. But concrete, like I mentioned, it has that high STC, that ability to stop sound transmission to start with. Wood does not have that, so it needs more. It needs more layers and more effort put into it to achieve that. So here's that light wood frame structure. So this is a great structure. Hitting a 62 in a light wood frame building, you've done pretty much as you can to achieve the best that you can. So the flooring type, the acoustic membrane, the concrete, every single one of those factors adds up to meet that STC and IIC number. So what is the issue with a light wood frame structure? Well, it's a lighter structure, very prone to flanking. And because of the weight, it needs weight, mass added to it. That's that concrete topping, or dry topping, as we're going to talk about coming up. So let's talk about these assemblies without talking. That's why everybody's here today. Well, that's why I'm here anyway. the, uh, let's talk about some of the big advantages firstly. Why should a developer, a builder, an architect, engineer, why should they switch to a dry topping? Well, it's more than just one factor now. This is what I say when multiple factors are all coming together right now. A, lowers the embodied carbon. This is huge. Later on, David's going to talk more about the sustainability, so I don't want to spoil it too much, but this is a big factor in every city across Canada right now. The East Coast more than the West Coast. I wish we were taken a little bit more seriously. Sequencing, big. So we have, when we're talking about drying time, sequencing with concrete can take a huge amount of time. If you're using an engineered wood or real hardwood floor, you can't put that down until that humidity levels drop to 8% per 100 square feet. With concrete topping, that takes a very long time. It can be longer than the typical 28-day drying time, even. So these are important factors. Humidity, a lot of time you can end up having to deal with humidity on site when you're drying your concrete or dripcrete. When we're talking about easy installation and quick execution, there's some videos coming up that'll show you how quickly these dry toppings go down. It's no joke. I had a project in Duncan, literally Duncan, British Columbia, Canada, West Coast, Vancouver, uh, uh, where we literally had an installer doing the dry topping one day in Unit A. He moved to Unit B. Flooring installer moved into Unit A. Next day, boom, 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 boom. The insulation, it was a magic show, to be really, really nice. No leveling required. So because every gypcrete and concrete salesman comes out and says, yeah, it's a self leveler. But every flooring guy I've ever talked to says, no, 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 no. I still have to account for my self leveling compound, however many bags per room in my quote, that never goes away. So that's a big, big thing to keep in mind. And then decrease charge over the structure. So when we're talking weight, concrete topping, gypcrete topping, 18 to 20 pounds per square foot. The dry toppings we work with are from 20, or sorry, from 2.2 to 5 pounds per square foot. Amazing drop in structure weight. When we worked with Woodworks BC on some calculations, their engineers said that reduced the structure weight by half. That's no joke. Cutting the structure weight by half is a serious, serious move. It's taken things to the next level. And even the guys that we're chatting with at warehouse are one of the biggest lumber suppliers out here in the West. Even though they want to sell lumber, they're excited about it too, because everybody kind of wants to get on not the green train, but the ability to find cost savings for their clients right now. So this is one of those innovative solutions. So this solution is when we're using recycled rubber and felt to come up with a solution. This is a Board from Suprema. Now, this product is specifically made for use with engineered wood and laminate floated applications. You can do other products over it, like an LVP or a ceramic, but then you're putting layers of plywood over top, which isn't always the most economic thing to do in today's world. So this product, I tend to say, perfect for your engineered wood floated applications because of how easy it goes down in these spots. And you're going to watch them do it right now very quickly. So as you can see here, these are some strips that will actually go underneath party walls. So if you're really looking to separate and help with lateral flanking between units, this is one way to go about it. I wish you'd go a little faster, but go faster. He's actually doing an amazing job. Look at I'd be doing this at half the speed. Because here's what I want him to do. Okay, so literally cutting through the polyester felt with an X-Acto knife. Brings it over to the edge, breaks the seam, cuts the rubber at the bottom. Boom, it's cut to size. It's when I say it's that easy, it is that easy. He's going to leave a small gap between the wall to put some acoustic caulking later, but he's going to walk away. That's Acoustiboard. Now that, without concrete topping, light wood frame building with the clip system, so Acoustivibe clip system, you're hitting above 55 on your ISC STC every time. Every time. And I have multiple projects on Vancouver Island, BC here that can prove that. Case studies probably later on to show you in this presentation. The next product I moved to, and this is David's favorite because it's what DCC distributes. This is kind of what I call the Ferrari of replacing replacing concrete toppings. So Fermacell is literally the one-stop solution. You put this down, it's a new floated floor that basically you can put any product down on top of now. You can do your LVP, you can do your ceramic, you can do your nailed down hardwood if you want. This product is literally designed to be compatible with everything. Very, very durable. In fact, we actually have started recommending this go down before the party walls. This will actually save with waste on site. So you can do the entire floor before the party walls go up. And then, like I said, very durable. You'll be able to work on it and get the rest of the construction job done at the same time. Now, this picture, you can see it has the clips and it gets you to 55 plus. I've got some examples and again, a case study down here that'll truly show you what this system can achieve all on its own. Now, this is what I call over the top. No, this system is our Sofix system, which was actually designed for mass timber. So this system on a light wood frame structure is going to just, shoot over the moon. It's a more cumbersome system. So the Sofix system is about 1.5 inches, and then it has layers of plywood on top of it. So again, a little more cumbersome, but when you're looking to actually achieve higher than 60 in a light wood frame building, you have to throw everything at it, right? You need the kitchen sink. This is the kitchen sink. This is what's going to get you what you need for a very high achieving light wood frame building. So it's cumbersome, it's big, it's thick. But the one thing you may notice on this drawing, they're running conduit underneath it. So up to 1.5 inches of conduit, you can run between those blue balls in the diagram on the left that are the supporting rubber balls for the material that treats the void space between that and the subfloor. So Sofix, great solution. I'm going to show you a case study later on for a mass timber building using this product. And I hope it blows your socks off because it did mine the first time I saw it. And actually the owner as well of the building, they were very, very impressed. Here we are now getting to mass timber versus concrete. Why do we compare them? Well, because mass timber is taking a swing at concrete right now. Mass timber steel structures. We've got 18-story buildings in the works now here in Vancouver, and I'm sure there's more on the East Coast as well. So what we're looking at here is where they start. So we know, as we mentioned before, concrete is good with STC, right? That sound transmission, it is always going to achieve more than 50. I don't care if you got a 6-inch slab, it's going to do it. It's going to get you better than 50. So there's no reason to deal with anything else other than IIC on that concrete structure. And as we showed you before, you can literally do that with one solution. One piece can do it all. So when we're talking mass timber, however, it is already doing poor on IIC and it's doing poor on STC because it has little mass to it. So where these both, again, are going to be similar to each other is they both have exposed ceilings, right? Everybody wants to see the beautiful mass timber ceiling, and everybody wants to see the beautiful concrete, well, not beautiful, but it's functional, a concrete ceiling. So in Vancouver, anyway, we don't have a lot of drop ceilings in our concrete buildings. I assume it's very much similar on the East Coast. But concrete and mass timber both expose ceilings. So what do you have to do when you're treating the acoustics? You have to treat it on the top. You have to do it on the floor side rather than the ceiling side. And because the mass timber, we have to address IIC and STC, that's a lot more work. On the concrete side, like I said, one product is going to improve that IIC. We put one of our textile mats in there, you're done. You're, sitting in your 60s, you're happy. But when we're talking mass timber, let's get right into it because it's not simple by any means. So mass timber structures, we know it's a lighter structure, more prone to flanking because of vibration. We see lateral flanking being probably the biggest issue in mass timber structures. Affected by code, we have STC and fire ratings, especially once we get above 6 stories. Decoupling is big. Like I said, no exposed ceilings. Having exposed ceilings becomes a big issue there. Talked about the IIC, very high growth industry competing against concrete. It has quite a few components that needs to get you there, like I said, to get to that high achieving acoustic numbers. Speed, aesthetics, environment, all reasons people are going to mass timber. We're seeing in, again, downtown cores where you can't have pump trucks closing the road up all day, whereas you can just bring a crane truck in and drop in some mass timber panels. Much easier in these tight, restrained areas. So yeah, lots of reasons to be going mass timber right now. It's not only a growing market, it is the fastest growing market I've seen in a while. So mass timber, like we said, I'm not going to do this too much, spend too much time on this one because we don't see it very often. Sometimes in office spaces, but not often at all. Suspended ceilings is not typical in mass timber. So there it is if you want it, but you can achieve high 60 fairly easy with that drop ceiling. Let's take away that drop ceiling, however. We take it away and we instantly are dropping to about 50 IIC, 50 STC. This is with a concrete topping with 2 decoupling membranes. This is almost exactly what we're seeing at most universities right now. So University of Toronto, there's a case study we'll show you, but I've got University of Royal Roads University here, the exact same thing they're doing in Victoria. So we have this is a very common installation on mass timber right now. But what we are trying to do is take that concrete topping away, right? Just like we were talking in those light wood frame buildings, we want these buildings to be green. You're putting in a carbon friendly product to start with. Let's not pour the most carbon unfriendly product in the world, sorry to spoil that on you, David, on top of it. It just doesn't make sense. So let's get into those right away. Let's literally jump right into it because this is what we're sitting at right now. This is literally the newest, the greatest, the best assembly out there for mass timber right now. Fermacell has the 2E35, which is a fire-tested panel. Yes, fire-tested panel that can achieve code numbers 50 IIC, 50 STC with one material. One piece going down, we can hit 50. This drawing shows it with sauna floor over top. That's getting you above 50. So we can do it with one piece. Everybody else out there, it's here's a structure. Now let's glue this on top and glue this on top. Here's some layers of plywood. That is one heck of an assembly. We're doing it in one piece, one amazing piece that meets your fire, your acoustic, sustainability. Again, we're all going to touch on this as we get to David, but this is huge. Very, very proud of this, and so is Firmacell. Please expect this in your next pro. But seriously, this is the way to go. This is the future right here. Sofix, like I mentioned, we're going to show you that case study getting forward, but this is where it's meant to be used. This buildup right here with like it's showing the two layers of plywood, even ceramic flooring, we're achieving higher than 55 IIC STC. Amazing. And this is an actual building tested in Brooklyn, done. We'll show you the case study. Very, very proud of this one. Sofix, like I said, it's the granddaddy when you're really trying to hit those high numbers. But before we get into those case studies, let's actually talk sustainability. And this is where I'm going to hand it over to David, because as a lead accredited gentleman, sorry to mess it up on you, David, but this guy knows his stuff, and he's going to tell you the reality of where we are today.
Well, thank you, Gordon, for sending me all these flowers. I appreciate it very much. My name is David Gonzalez. I'm a low-carbon building materials ambassador at DCC Solutions. And I just want to clarify right away, I'm not in any way related to Speedy Gonzalez, for those that know the character. I am, however, an accredited lead green associate, and I'm really, really passionate about green buildings and eco-friendly construction materials. So I'm really delighted to share with you today the environmental benefits of dry topping solutions, especially for wood frame constructions. So I think most of us attending this webinar, I think we're invested in promoting the virtues and benefits of wood construction. So I think this is one of the main reasons why we strongly believe that using dry toppings to improve the acoustical properties of buildings is also going to contribute in reducing the environmental impact and minimizing the carbon footprint of any building, that it be in wood or any other structural material. Go ahead, next slide, please. So I think we're all well aware of all the various natural disasters that plagued our planet over the last few years. Next slide. The Aon Insurance Company mentioned in its 2022 report that the planet was hit by weather damages that caused over $29 billion worth of damages. So we can't doubt anymore that climate change really is having an impact on all of us. So according to the available data, the construction and operation of buildings represents almost 40% of global greenhouse gas emissions. Out of those 40%, 70% of those emissions come from the operational activities like heating, air conditioning, lighting, and the remaining 30% comes from the embodied carbon of materials and processes that are used in the construction of buildings. So there's a lot of public pressure right now on all industries to find solutions to minimize GHGs. I think we have to look into optimizing the energy performances of buildings, but we also believe that the decarbonization of buildings requires the leadership of public authorities. Next slide, Gordon. So most cities today are encouraging the use of various strategies to decarbonize its building stock. I think by improving the energy efficiency of buildings is one way of doing it. And by replacing also the systems that still run on fossil fuels. But other professionals are also proposing a more aggressive approach in reducing the environmental impact of buildings, and that is to avoid using materials with a strong carbon footprint like concrete and steel. So embodied carbon really has become an area of focus in mitigating climate change, with a lot of jurisdictions and federal governments that are moving towards setting performance targets and requirements. There's already various municipal governments that are following suit. We have the city of Montreal that is requiring by 2025 that all new constructions on its territory be zero emissions or net zero. Toronto is also taking action by imposing embodied carbon targets for new construction with its so-called Green Standard Plan. And just like Vancouver as well, Vancouver has its climate action plan that's being used as well. I think also our friends down south, our neighbors down south in the USA, there's some states also that are taking big steps to bring forth procurement policies to reduce embodied carbon in their respective territories. So all this is really going to have a change in the industry. Next slide, Gordon, please. So according to the United Nations Intergovernmental Panel on Climate Change, 20% of global GHG emissions are really attributable to two building materials, cement and steel. Now, according to these experts, apart from the energy efficiency, they're also recommending to reuse unoccupied buildings to avoid consuming carbon-intensive materials, and preferably choosing maybe ones that are going to be lower emitting ones as well for newer construction. So how do we achieve that? Gordon, next slide. One way is to favor the use of wood in construction. But why is wood better environmentally speaking? Well, using a wood frame structure allows the building to really be part of a true approach to reducing carbon dioxide emissions, because 1 cubic meter of wood can actually store 1 ton of CO2, while 1 cubic meter of concrete is actually going to emit a half a ton of CO2. So there's no doubt that wood construction really is experiencing a real boom in Canada and elsewhere in the world. And that's why we think that building with wood is actually going to allow for sustainable transition in the construction industry. But as I think Gordon explained it well, is that there are a lot of acoustical challenges present for soundproofing in wood frame buildings. Gordon, next slide. So in the industry, we know that to soundproof floors, usually in wooden structures, there's usually three solutions that are commonly used in the industry. We have regular mortar beds, or we call screeds or sand coats. We have concrete toppings or self-levelers, or AKA gypcrete, which belongs in the category of what we call wet screeds. And then there's the dry toppings that Gordon showed us previously. That is an alternative to the solutions that contain cement. So that's what we're hoping to change in the industry. Next slide, please. So there was an interesting study that was carried out by an organization that's called FP Innovations. And they focused on a mass timber building that was constructed in Montreal called Arbora C. So the purpose of the study was to determine what is the carbon footprint of this building if it's built in wood versus concrete. So the initial difference was a 20% reduction right off the bat just by building it out of wood compared to concrete. But they took the analysis just a bit further, and they wanted to assess, well, can we reduce the building's carbon footprint even more by replacing some of the materials and systems that are used with lower carbon alternatives? So to summarize quickly the study, what they evaluated is they took 10 scenarios and they said, what can we do to change and lower the embodied carbon of it? Now, the biggest impact on the carbon footprint of that building was when they replaced the concrete topping with a dry screed system. In this case, it was this Fermacell system that was considered. So just that scenario alone theoretically made it possible to reduce the building's GHG emissions by almost 8%, and also eliminating around 1,600 tons of concrete and 3.3 tons of plastic. So what the conclusion of the study means is that all the decisions and the choices of materials that are made during the design process of the building, specifically if it's done in the preliminary stages, can really have a significant impact on the total carbon footprint of any building. In the case of the Arbora C building, if they had taken all the eco-design choices and put them into application, the total embodied carbon footprint of that building would have been 35% lower. So let me ask you a quick question, and I know you won't be able to answer, but here it goes. How does a 1.5-inch concrete topping weigh? Now, Gordon mentioned it before, we're talking about 15 to 20 pounds per square foot. Next slide, Gordon. So by knowing that, do you think that there's material gains that are achievable when you could subtract a minimum of 10 to 15 pounds of weight per square foot from your structure? Now, these are all advantages the dry screed systems bring to the table. I'll list a few of the possible options that could be done. I mean, right off the bat, with less weight on the structure, you could have your floor joists that are smaller and more spaced out. In extreme cases, you could build on soils that are less load-bearing without having to pile the foundations. You could add an extra floor without having to reinforce the structure. And foundations that support less weight can also be narrower, and it can use less concrete and steel rebar. So these are all actions that reduce the carbon footprint of buildings and help achieve zero emission goals. Gordon, next slide, please. So we've talked a lot about carbon footprint, but I also want to elaborate, how do we determine if a product it really is good for the environment, if it's really considered ecological? So we've probably already have heard that term, what's called greenwashing. That's when companies exaggerate the environmental properties of a product by promoting certain features with a lot of unsubstantiated claims. So one way to combat these misleading practices is to request for reports and certifications from independent and recognized organizations that they're able to justify the environmental characteristics of products. So one of these documents is what we call an environmental product declaration, or in short, an EPD. It's pretty much comparable to a nutritional label that's found on food. And it's a way for manufacturers to quantify the environmental impact of their products by following protocols that are under an ISO international standard. You could also use or request for health product declarations, which provides a complete disclosure of the chemical substances that could be a possible concern in products. What about recycled content? That's another aspect that has to be considered because it's part of the circular economy. Also, we spend, I think, almost 90% of our time indoors. So there's a whole aspect regarding VOC emissions from materials we call off-gassing that has to be considered as well. So there's all other kinds of certifications that exist. There's Eco Institute, Green Guard, FSC, Cradle to Cradle. So these are all certifications that are available with a majority of the dry topping solutions that we represent. Next slide, Gordon, please. So let's talk quickly about LEED. I think I get asked this question very regularly. Are products LEED certified? Well, the answer is no. The LEED certification is going to certify a building, but it's not going to certify a product. However, certain of the dry topping products that we represent, there's characteristics in there that do contribute to obtaining points for credits that will help obtain LEED certification for a project. So if you see at the bottom, there's a little table there. That's the upcoming version of the LEED, the version 5 LEED scorecard that's going to be coming up very shortly. And they're putting a lot of emphasis on embodied carbon, as you can see in the chart. So that brings me quickly at the end of my intervention. I do want to leave you with a little moment of reflection. I think with the climate challenges that we're facing today, the construction industry has to stop using the excuse of, like, we've always done it this way, so why should we bother changing? We have to dare change the existing mentalities in order to bring the industry to favor innovative solutions that are less non-toxic, they're ecological, lower embodied carbon, because at the end, that's the pinnacle of environmentally friendly architecture. So that concludes my part of the presentation. Gordon, I'll hand that over to you for the final section. Thank you very much.
Beautiful. Thank you so much, David. That's always my favorite part of the presentation. I tend to pick up new nuances out of it every time. And I probably one of the number one things that I bring to people's attention is that EPD. It is such a valuable tool, especially when you're dealing with government agencies, because they want to have that instantly. And if you can have it available to them right away, it makes it a much easier process for them. So thanks a lot, David. Yeah, so touching on some takeaways here, this is essentially what I'm hoping you get from today. We are here to prevent noise complaints. Literally anything we can do to help you with your structure to achieve that. That's what I'm here for. David and I, we spend most of our time dealing with architects, developers, just finding the best solution for that structure. Now, that's not always going to be, 60 IIC, 60 STC. It's what your developer engineer team is calling for, right? So there's a lot of factors that go into that, and we're here to make sure the right stuff, right product goes into the right place there. Acoustics are mandatory in multifamily, absolutely, especially in light wood frame buildings. I'm seeing a lot of developers that are shifting from concrete to light wood frame, and they need to understand that there is a difference acoustically when they make those changes too. Rating equals assembly, a big one to take out of this, right? I kind of harped on it. A product does not equal an assembly, just like David said, a product does not equal a LEED certification. It's the assembly or the building, as Dave said. So please keep those in mind as we're going forward. And please use us as an extension of your team. We work in complete confidence with whoever we are working with. And if you need us to sign NDAs, we can, but trust me, they're not required. We will work with you in strict confidence to make sure your customer gets what they're looking for in their development. So please take advantage of us. Our request process is very, very simple. We just take a look at the architectural plans. We're going to refer to multiple, we're big data-driven companies, so we're going to refer to multiple documents to make sure that we give you the best possible solution for that. And we'll recommend them based on what you're looking for in that situation. Like I said, it's not going to shoot for the moon if you're only aiming for Mount Everest. Let's do what's needed. This is huge. I usually at this point go, hey, check out our recipe book, but we now have our Acoustic Index back on our website. Please, if you haven't, check it out. It is the end-all, I would say, on acoustics and assemblies. You can type in what assembly you're looking for, what products, flooring products you're looking to use, and it will give you sample assemblies to work with. It's not going to give you everything, but it's a good starting point. You can contact us for more details. But we will be adding a pro section to that website. So if you're an architect engineer, email us, let us know that you'd like to be registered for that, because I think that's going to be valuable for everybody out there. While we still have some time, let's do some Q&A. I'm sure there's got to be a couple questions out there. I'm not sure if Allison, you can unblock everybody's, or if they just want to even type messages. I'm not sure what works easiest in this situation.
No question for the moment.
Perfect. The next slide here has my contact information on it. So please, if you have any questions that you haven't been able to voice here today, please email us, call me. I'm on the West Coast, but I will definitely help you out on the East Coast while Christian's away right now. So definitely give us a call. We're always here for any acoustic needs. I can put you in touch with David as well if you have further questions regarding LEED or any of his products as well. So really, thank you everybody for coming today. It's not easy to take an hour of your time to listen to somebody talk, but I hope it was worthwhile for you.
Thank you so much, Gordon and David. Have a good day.
Our pleasure.
Take care, everyone.